All right, it is now 8:30 a.m. Let's go ahead and kick this off. I want to welcome everybody to Code PaLOUsa 2020. This is, I think, my 8th or 9th time speaking at Code PaLOUsa, and it's always a pleasure to be here. I want to thank our organizers and sponsors for inviting me back again. And today, we are going to be discussing something that may sound a little shocking to you. So about 2 years ago, I started seeing posts like these that you're seeing on your screen. And in recent months, I've started seeing them accelerate with people from Uber, Netflix, even Google starting to talk about the many places where microservices don't necessarily make sense. And what you're starting to see is there's a trend, especially in small and medium, even into the smaller, large enterprises, of going back to the whole concept of monoliths. But they're doing it in a very particular way, which we'll discuss. And this kind of makes sense if you've ever watched any of the Gartner stuff or any of the trending stuff. There's this concept of the hype curve, right? So expectations versus time. Microservices, I feel, is right about here. We're about to hit the trough of disillusionment. We all got excited about them for a few years. We all tried to use them everywhere and follow after the big FANG companies, the Facebooks, the Amazons, the Apples, the Netflixes, the Googles. And what we realized is microservices are great for that size, that scale, but they're not necessarily great for all of our organizations. Sorry, I'm going to take this off. It's a little distracting. Over time, we've gotten saturated in a new way of working because everyone is chasing unicorns, but eventually we hit that trough of disillusionment. We realize that the way we're doing things only makes sense in certain environments or certain scenarios. And finally, the industry is coming back to its senses, and we apply these new methodologies more carefully and with more serious thought. Not every technology or methodology goes through these phases, but most of the disruptive ones do. So the title of this session, Majestic Monoliths Are the New Microservices. Everything old is new again. And my name is Devin Phillips. I'm an architect with Red Hat Consulting's Cloud Native Runtimes practice. In the Cloud Native practice, my team and I work with customers big and small to help them implement their business needs while trying to keep in mind developer productivity, fast feedback cycles, code maintainability, and many other factors. I've been developing software professionally since about 1993. One of my first after-school jobs was writing software for a Xenix high-speed laser printer system. I've been developing microservices and with containers for about microservices for about 15 years, containers for about 8 or 9. And I've been using Kubernetes and OpenShift for container orchestration for about 5 years now, 6 years now. I'll tell you this so that you understand that I've been doing this a long time in the trenches with real customers and real use case scenarios. So let's talk about the good old days. When I first started developing software, most applications were monoliths. It was a single code base running on a single machine and using shared memory or inter-process communication. No need to worry about TLS encryption, cross-origin requests, cross-site scripting, SQL injections, service mesh, availability zone outages, DNS problems, cache expiry, and content distribution networks. It was a much simpler time. That's not to say that monoliths didn't have their downside. One major one being that if you needed more power than your single machine could give you, you had to either buy a much bigger machine or move to a different monolith altogether. After a while, once you've upgraded to the biggest machine you could afford, you might be stuck living with a monolith which wouldn't scale to meet your needs. This is a problem, But it wasn't nearly as widespread as many of us have been led to believe. In fact, it was generally only very large enterprises who would run into these issues regularly. With the advent of the public cloud, this is even less of a problem because you no longer have to buy a completely new set of hardware every time you reach capacity. You just move your application to a larger VM and add more memory, add more storage, add more CPU. Another thing to consider is generally your limiting factor was the database. In the cloud, your database is as big as you want it to be. You don't have to forklift upgrade your database. You just tell RDS to give me more queries per second or more IO ops. In the cloud, your database is as big as you want. Also, if you're running on-prem, there are now much more modern, accessible technologies around allowing you to shard your databases so you can distribute that workload across many smaller servers without even having to break up your monolith. Another problem which monoliths often suffered from was maintainability. It can be very difficult for developers to maintain extremely large code bases. This often led to release schedules measured in years instead of days. Those vendors who could move in a more agile fashion often had a significant market advantage over those who couldn't release early, release often. So then microservices came along and takes the stage. When I first started developing microservices, I was told about the advantages of using them in that, one team, one service, lower barriers to entry, faster releases because of loose coupling, more scalability because you can stand up multiple instances of a single service or just a single instance, and you could elastically scale up and down, and you could move fast and break things. All of this sounds great in theory, but let me ask you, have any of you actually ever released a single microservice of a multiple microservice application without very, very careful and thorough validation and integration testing? I can tell you from my perspective, very few of my customers have ever done that. Their integration testing phase is often longer than their development and implementation phase. As to scalability, I can honestly say that I very rarely see customers who need to quickly scale up their applications in the way that FANG companies do. And when they do scale their applications up, it's often just one or two services and not tens or hundreds of services. Let's also ask the question about managing and maintaining microservices. As developers and operations people, we now have to deal with service mesh, distributed tracing, TLS, encryption in flight, SQL injections. We've traded one set of problems for another, and in many cases, the cure can be worse than the disease. But what if we could take a sort of a hybrid approach? With microservices, we were promised that we could move faster by decoupling our services. But is that really only a feature of microservices? Couldn't we do that with monoliths as well? Lots of languages and frameworks support modularity via libraries and service programming interfaces. With microservices, we were promised we could scale quickly and easily. Again, is that only limited to microservices? Couldn't we individually scale certain services using multiprocessing, multi-threading, and queues for most things and only resort to an external service when absolutely necessary? And I can say that faster releases were not really ever that common with microservices in my experience. But I think that the concept of a modular, or better yet, what a lot of people are starting to call a majestic monolith, we could do much better. I, for one, miss a lot of those compile time guarantees I would get when building monoliths. What if we could get that for our business applications and still be able to spin off certain services when it makes sense and easily? Now, I love this quote from Martin Fowler. I don't drink all the Martin Fowler Kool-Aid, but he definitely raises very good points on a regular basis. And his point here was, in his experience, almost all the successful microservices stories started with a monolith that got too big and was slowly broken up. Second, almost all cases where he had seen a system that was designed from scratch to be microservices ended up in serious trouble. And I can somewhat echo that. I've seen where projects that started off saying, hey, everything's going to be microservices or functions or serverless from the get-go, you usually end up with a bit of a tangled mess. And the reason for this, and what Fowler really says when you read more deeply into his writing, is that it's often better to work out the architecture of your system as a monolith first. Or if you already have a monolith, improving the architecture of your existing monolith should be your first priority. Once you have a clearer idea of that architecture, only then should you consider finding the portions of your application which are constrained, and only break out those services that you need to break out. So again, let's look back, the good old days. And I'm not saying this wasn't problematic. There are problems with this. As a developer, working on this big abstract box could be intimidating. For something like an enterprise resource planning system, these things were huge, and they covered so many different domains like accounts receivable and billing, accounts payable, logistics, manufacturing schedules, customer service, customer history, financials tracking, marketing, credit history, customer lead and relationship management. That's a lot of stuff. And if the application is not well maintained, it could easily become a big ball of mud where it's difficult to tell where one capability ends and the next one begins. This means that your developers, you, have to become subject matter experts in all of those domains. Now, let's think honestly for a second. If I'm being honest with myself, writing code is the easy, and I would say fun part, of my job. What is not easy for me is making sure that I understand the business side. So if I were to say, leave Red Hat, go to work for a line of business company like Acme Widgets, I know nothing about Acme Widgets and what they produce and their customer base and how they do business. I know how to write code. So when I look at their code, I'm immediately going to be lost because I don't know their business. So as a developer, I need abstractions to make it easier for me to start to understand their business. This is also where having good product owners and business stakeholders is vital. You need people who are immersed in that line of business with whom you can interact with regularly and who can help you as developers understand the needs of the business. So we didn't like this big abstract box. We didn't like forklift upgrades. We didn't like being constrained by our monoliths. And we saw these new cloud native companies like Google, like Facebook come out with their microservices architectures. And we've broken things down into more manageable chunks, which are easier for developers to reason about. You don't any longer have to be a functional expert in every area of the business. And you can specialize and not have to context switch as often. The downside is that we've lost some compile time guarantees, and we've also made it more difficult for integration of these different modules. And we've added a lot more complexity with things like secure sockets, latency, cross-origin, cross-site scripting, multiple databases, more configuration, all the interconnecting networking and DNS, etc. There's a lot of complexity with microservices. So if we start to look at that hybrid approach, the first step in that is what is generally referred to as a modular monolith. In a modular monolith, each module is its own code base, just like it would be in microservices. It's built in its own pipeline, Jenkins, TeamCity, whatever, GitHub Actions, Travis CI, you name it. Each code base is owned by a single team, though a team might own more than one module if it makes sense. And so they can move at their own pace. Each module has its own separate release cycle, which doesn't have to impact the rest of the application, as long as there's no breaking changes in the APIs. And a quick run of your compiler will tell you if you've broken anything in those APIs. So this is actually really nice and simple because we get those nice compile time guarantees, but our teams can still move individually. Then what you can do from there is you'll see that once you get toward a modular monolith, you'll see it often evolve into what people are starting to call a majestic monolith. The majestic monolith makes those module boundaries strict. There are no ways for, say, the accounts receivable module to call the internals of the ordering module. It all has to go through this strict interface. For example, in Java 9 later, you can use Java 9 modules to enforce that. In .NET, you can, in a single CS project of a multiple project solution, you could set disable private reflection so that nobody can call directly into your code. They have to only call through the interface. This allows your development teams to work independently on their modules without concern about breaking existing integrations. Also, disabling reflection can help you find where those violations of those boundaries are and give you a relatively easy path of solidifying those boundaries and eliminating the big ball of mud problem. As demands on the system grow, they're often limited by the speed and I/O for the database. So before you consider breaking off a microservice, maybe one thing you consider is sharding your database. So maybe your main portion of your monolith is using one database, but your ordering system is taking a lot more I/O, a lot more load. And so you shard that portion out. Now, to your monolith, it still looks like one database. You can use something like data virtualization or Postgres foreign tables to make it all appear to be a single database to your application, but the I/O is distributed across multiple machines. And that can often be sufficient to alleviate constraints. And then as long as your modules are sealed and everybody is respecting these strict interface boundaries, if you still have performance constraints and you still need to scale your application, when it makes sense, you can start breaking components out into small microservices or smaller macro services. As long as the API contracts remain the same, the application looks and feels internally identical. But now those API calls, those interfaces, are actually API calls across the network over HTTP or messaging or gRPC or whatever. And keep in mind, those services don't have to be micro. We can decompose services where it makes sense for the business and for the problem domain, not based on the size of the component. And in addition, our API gateways or our service mesh basically makes this completely transparent to our end users. They still see the application exactly the way it was before. And thus, once we have maybe our catalog service, our ordering service broken out, we can scale that by itself and not have to worry about impacting the rest of the application. Some people are starting to call this concept the Citadel. So you have your main fortress, which is your monolith, and sometimes you need to put an outpost out there, and that starts building out this Citadel concept. So you might be thinking modular majestic monoliths sound great, but how do I get there? Well, there's one common step you should take in this journey, and that is the adoption of domain-driven design. People like Eric Evans, Von Vernon, Alberto Brandolini, and others have written extensively about DDD, and you'll find that by using practices and principles around domain-driven design, you can quickly understand where these contextual boundaries currently exist and where they should exist going forward. I recommend reading Von Vernon's Domain-Driven Design Distilled or reading some of the work by Alberto Brandolini. Eric Evans, the quote unquote father of DDD, his writing is great, but it's very academic. Vernon and Brandolini are more applicable to the real world quickly. So let's walk through what that might look like, right? With an example. There is an application out there on the internet you can download called ADMPierre. It's an open source enterprise resource planning system, and it incorporates all these different modules. It is a single monolith. It's written using Maven submodules in Java, but this could easily be applied to C# and .NET and other languages. So ADMPierre has customer relationship management, point of sale, human resources, all the things a small to medium business needs to run their organization. Those modules that are contained are diagrammed here. It's also broken down into modules along what are called bounded contexts in terms of domain-driven design. Tightly related portions of the application are collected up into a single module. Modules, communication between modules, have looser couplings, and they're defined by interfaces between those or contracts between those modules. So if we zoom in on one of those modules, we might see the point of sale system has a lookup interface, an order interface, a query interface, a catalog interface. And if it's implemented properly, the only way to interact with this module is through methods exposed in those interfaces. So suppose the POS module is a bottleneck. It's processing too slowly. Your customers can't browse through your catalog quickly enough and see your products fast enough, and they're going to other websites or other vendors. Everything else in the monolith seems to be working fine and it's handling your needs. Well, first, we can shard the POS portion of the database off. Well, I did not fix that animation. Sorry about that. There was supposed to be a little database icon pop up down there. So we could shard the database and put the IO operations for the point of sale system or maybe just the catalog service onto a different database so that we have a separate set of IO ops. And we can do that with Red Hat has a product called JBoss Data Virtualization, which allows you to sort of present multiple databases through a single database interface. So they look like a big single database with caching and everything. Or you could use something like PostgreSQL's foreign table wrappers, which allow you to connect to a single Postgres server, but it can actually be a front end for multiple different databases. It could be more Postgres servers or MySQL or Oracle or Microsoft SQL or whatever, but it all looks like a single database to you, but you've distributed that IO to multiple pieces of machinery in the background. And if you're still experiencing capacity issues, well, then we can take those existing interfaces and map them to an API over the web or over a message queue or using any other method we deem appropriate. As long as we maintain that interface, the client library for that interface, none of the other code in the monolith needs to change. We've successfully extracted a single module into a microservice or a macroservice. We could implement the entire point of sale system module as a macro service, or we could just maybe extract the catalog interface if that's the only part that's constrained. It depends on our needs, what's the easiest to manage, and what's going to provide the best value for our organization. There's also tools that can help us in extracting these services in a much easier fashion. So we could use OpenAPI to do contract first API development. You write your OpenAPI spec. I can go on about this for hours. It's one of my favorite topics, but we'll just say that you write the contract first, generate most of the code, generate client libraries. It's really nice. Similarly, you can use gRPC for that or Google RPC. And then GraphQL is starting to become a common way of doing this. But in the end, everything inside the application looks identical to the way it used to run in the monolith, and the interfaces just provide a simple, thin layer between your monolith and one broken out or 2 or 3 broken out microservices. So what are the key takeaways that I want you to walk away with today? Microservices are not necessarily the best answer for everything. And in my opinion, maybe not Red Hat opinion, but my opinion, they're probably only good for a few things or for certain types of companies. Modular and Majestic Monoliths can move as fast, or in my experience, faster than microservices. The cloud negates a lot of that old forklift upgrade problem. Database sharding and virtualization may be a better first step than considering strangling your monolith. Microservices introduce a lot of complexity, and if you have not thought it through very well, trying to adopt microservices can be a disaster waiting to happen. Modules reduce cognitive load on developers and provide abstraction. So instead of having to be a functional expert in every aspect of the monolith, I only have to be a functional expert in my module. Modules should be broken out into separate services only as needed, only when you're hitting resource constraints that are not otherwise addressable. And modules should be determined with the help of domain-driven design. And actually, my colleague, Jeremy Davis, is going to be talking about event-driven architectures tomorrow afternoon. And he's going to talk a little more in depth about domain-driven design and some of the practices that you can use. So with that, that's all of my slides. I am open to questions, and I would like to direct you to the services blog at Red Hat or the developers.redhat website, where we write about a lot of this stuff. I will also try to let the community know my team is going to be releasing a series of YouTube videos about contract first API development in the near future. And those will be applicable regardless of language framework. They're not Red Hat specific technologies. These are practices. These are ways of working. They're not technology related. Well, somewhat technology related. And I'll say thank you. Now, let's open it up to questions. Anybody have any questions they would like to have answered, or any questions for me about the content? Looks like we have one request in the queue. Hello, Danny.
Hey there. So actually, I have the same question that that Jeremy has in the chat. When do you think it makes sense to do microservices?
So if you're doing your applications fairly well, you should have some sort of performance monitoring. Whether that in the Java world, it might be JMX. In the Windows world, it might be Windows performance metrics. When you see that you're either IO bound, CPU bound, or memory bound, and it's going to be prohibitively expensive to just upgrade your machine. Because you've got to think about the expense of rewriting software, right, of the developer time, and of potential bugs, and the management overhead of microservices. Those all cost money. They all cost time and resources. And so you've got to really think critically about balancing those costs.
Okay, that makes sense. Thanks.
Cool. Any more questions? Or is it going to be a very quiet 15 minutes until the end of the session? Oh, wow. Either I did a really good job or everybody's kind of sitting back there, this guy's nuts. Well, then we can just have open discussion about whatever topics. Does anybody have any questions that maybe aren't related to the session? Well, thank you, everyone. I appreciate the positive feedback, and I will also get these slides to Chad to distribute to everyone You'll have all of the source links at the bottom of each slide to more information about the various topics, links to some of those books and writers that I spoke about, and links to some of the blog articles that I've been seeing about Majestic and Modular Monoliths. So keep an eye out for those slides. Worst case scenario, follow me on Twitter at infosec812. I'll put that in chat. And I will post the slides later today so that you can download them. Unless there's any more questions, thank you for your time and have a really good time at the rest of Code PaLOUsa.
Thanks, Devin.